All right, hello everyone. Today we're on section, I didn't write it down, 4.2, I think, implicit differentiation. I'm just going to give you two examples, quick review. I hope you remember this. I'll kind of explain why the process works and just give you two little examples. This section is titled implicit differentiation. So far, you've learned how to take derivatives, lots of different types. When you have a function written as an explicit equation, this is called explicit. Y is defined explicitly in terms of x. Okay, but all of our functions aren't that way. If you notice the one I have up here in the green, get rid of this one. The green one, y is not an explicit function of x. It's x cubed plus y. You got y's and x's together. Could you solve that for y? You could try, but it wouldn't be very much fun because of the y and the y cubed. So we're just going to go ahead and differentiate it the way it is. It's called implicit. But it's with a little understanding that let's just pretend for a second that you could solve for y. So remember, if you took this and if you keep thinking about that there is some function, so that y could be described just in terms of x, that's going to help us remember how to do this implicit differentiation because of the fact that we have to use the chain rule in essence. So I'm just going to actually come down here and write that same problem again, x cubed plus y cubed minus 9xy equals 0, and walk you through it. So we're going to take the derivative. We're still looking for dy dx. So the question is find dy dx, right? So this term is already in terms of x, really easy to deal with, just like we normally would. It's just 3x squared. Here's the catch, right? So a lot of people just want to say this is 3y squared. But the problem is that y is some function of x. So just remember, as you do these problems, this is a big remember, y is some function of x. So when I take the derivative of y cubed, I just can't say 3y squared because y might be 2x squared plus 4x minus 1, all of that to the third power, which means I'd have to drop the power to the second power and then do the chain rule. So we're going to do the same thing. So it is going to be 3y squared, but remember, if you think about it up here, this was like some function of x to the third power, right? So the derivative would be 3 times that function of x to the second power, which is what you see me do right there, 3y squared. But then I have to multiply by the derivative of what's inside, which is f prime of x. Okay, and that's actually what we're looking for, right? We're looking for y prime. So I'm going to tack on a little y prime right there. That's that f prime of x in that one. Same thing on the next step. Be careful with this minus sign because this is a product rule. I'll change colors here so you can see it a little bit better. First term is 9x, so the derivative of that is 9 times the second term. I'm going to put this in parentheses so I don't mess up that minus sign. And now we have a product rule. The second term is, whoops, let me get a better color for you there, sorry. The second term is y, so the derivative of that is y prime times the first term, which is the 9x. And the derivative of 0 is 0. Notice every time there's a y prime that goes along with it. That will always happen. Got to remember this. You first do this, it's a little bit weird, but if you just keep in mind that every y is some function of x, you have to do the chain rule every time you see that y, okay? And after this, it's just a big, gigantic algebra equation, which is trying to find y prime. So what we're going to do, we have 4 terms, 1, 2, 3, 4. 2 of them have a y prime, 2 of them don't. This is just algebra. So we're trying to find y prime. So what we're going to do is keep the y primes on one side and the other things on the other side. Doesn't matter which side you go to. So I'm going to leave the y primes here, which I guess would be, whoops, let me try that again. Sorry. 3y squared y prime is going to stay minus 9xy prime. Okay, don't forget that my sign. And then I'm going to take the other two terms over to the other side, so equals negative 3x squared. And this is a negative 9y here, so it's going to be a plus 9y on the other side. I'm solving for y prime. I'm going to factor this side, 3y squared minus 9x equals negative 3x squared plus 9y. Divide, and you get y prime, which is what we're looking for, negative 3x squared plus 9y all over 3y squared minus 9x. That's your dy dx. Notice there's still y's in the answer. That's going to happen. We don't know what y is, right? From the beginning, we didn't know what it was. We could, if we had the mathematical ability to solve that equation, we could have, but we don't. They're not going to be simple enough to solve. Otherwise, you would just solve them and do the derivatives the normal way. So it's totally okay to have y's in the answer. There's going to be a little algebra skills here, like trying to solve these equations. Some of them get a little different than others. So that's the basic idea of implicit. I'm going to do one more because my next question is actually going to ask you to find a second derivative. Okay, find a second derivative. So I'm going to scroll down here. I'll do the same problem. And we're going to find the 2x cubed minus 3y squared equals 8. The question is find the second derivative. So we're just going to go through the same process once, okay, which is find the first derivative, just a little practice. So this, remember, anything with just an x, no problem, normal, 6x squared, right? Minus, now, this is a power rule, but it's also a chain rule because remember that y is some function of x. We're going to drop that power. It's going to be 6y to the first. And then I now need to apply the chain rule, which gives me this y prime. And be careful here, the derivative of 8 is 0. A lot of times people leave that 8 there. I'm going to do the same thing I've done before. Negative 6y, y prime equals negative 6x squared. Divide through negative 6x squared over negative 6y. I'll do a little simplifying, I guess. And we get y prime equals x squared over y. Remember that it doesn't matter which side of the equation you go to. So if you have an answer that's all opposites of what I do, it just meant you went to the other side. Be fine. If I go back to this one we did up here, a lot of times if you went to the other side, that'd be positive, that'd be negative, this would be negative, and that would be positive. So now I want the second derivative. So I have the first derivative, so I just got to take another derivative. It's going to be a quotient rule. Often it's going to be a quotient rule because of that division. So now we go y double prime. It's a quotient rule. So quotient rule is derivative of the top, which is 2x, times the bottom, which is y, minus the derivative of the bottom, which remember is y prime. It's not 1 because y is some function of x, times the top all over the bottom squared. There's the second derivative. One little catch. Notice in the first derivative, we leave y's in there because we don't know what y is. In the second derivative, we have y's. We don't know what they are, so we're going to leave them alone. We have a y prime also. But the thing is, we do know what y prime is, which means we got to put it in. So we're going to go y double prime equals 2xy minus that y prime is x squared over y times x squared. Don't worry about simplifying these problems. I don't care. Simplifying is just extra work. I know you got a lot to do. Anytime you take derivatives, just go ahead and take the derivative and don't worry about simplifying. So that's a little review of implicit. There might be a couple other examples in the book if you want to check those out. Hopefully that's enough to get you going on the homework. And let me know if you need help.